Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. And I'll be going through test number 3 review. If you look at the end of the test 2 test, but I better do it again, let me just remind you. This Thursday, the 10th, I'll be giving test 3. It will cover carboxylic acids, esters, carboxylate anions, the amine salts, quaternary ammonium salts, amides, and heterocyclic compounds. Actually, all stuff I worked a lot in, near and dear to my heart, in the chemical industry. I work with a lot of functional groups in the chemical industry, which is rare for industrial chemists. But anyways, it'll have the same type of format as test 2, just different functional groups. There'll be 7 general knowledge, 38 nomenclature points on nomenclature, give the IUPAC or common name, or draw the structure, and 60 points on reactions, give the organic product or products, and I'll have 3 or 4 reactions, give the starting materials. And as I just mentioned in another video, if you go to content, the lecture, since I already opened it up at the bottom, for you, when you first type it, there'll be a load more button. Oh, it's back again. You click on the load more button and scroll down, and you'll see test 3 review as a Word document and a PDF file. Everything I'll talk about or everything that you need to know for test 3 will be found in that review, which I'm going to go and do now. All right, let's go through test number 3. First functional group, carboxylic acid. Carbonyl with the OH group, remember carbonyl, carbon, double bond oxygen, and an R group. How do you name it? You find the longest chain with the carbonyl carbon, name it as an alkane. Drop the E, add OIC in the word acid. You never put a number, just like aldehydes, but the carbonyl carbon is always number 1. Now, I asked you to learn 3 common names. The simplest, one of the simplest carboxylic acids, when R is a methyl, nobody ever calls this ethanoic acid. The common name is acetic acid, and 4% of that, and 4%, actually 96% water. And we have a special name for this, and that's vinegar. When I ask on a test, give the name of a product you use in your daily life and name the molecule that's in there and what's the functional group. Well, I did it on test 2. Well, but vinegar is 4% acetic acid, a carboxylic acid, 96% water. Next, I talked about when R in a carboxylic acid is a hydrogen, that's formic acid, and that's the chemical weapon fire ants use. And finally, when R is a benzene ring, IUPAC in their infinite wisdom said, well, we're never going to change these organic chemists. Let's use the old name, benzoic acid. And they did. All right, now carboxylic acid. Remember, an acid is a proton donor, something that gives up H+. If you have a carboxylic acid, react it with a hydroxide base, or M for my class, there are others, but I'll just stick to this, lithium, sodium, or potassium, you will get a carboxylate anion. You remove the acidic proton, which is this hydrogen right there and make a salt, carboxylate anion. All right, now a special one, which is very near and dear to my heart, because this is the first reaction I ever did. My father taught me this when I was about 5. And go back and look at the video about the little rocket ship. I just remembered, I have a photographic memory. I can see myself playing with that. But anyways, carboxylic acid and sodium bicarbonate, that's NaHCO3. Also known as baking powder. You react it, you get 3 products. And this is one of the rare times when I ask students give all the products, not just the organic product. And you get this carboxylate anion, you get water, and you get carbon dioxide, CO2, given off as a gas. How do I know it's a gas? The arrow right here pointing up, not the one I just drew pointing down, but you know what I mean. Now, how do you make carboxylic acids? If you take a primary alcohol and oxidize it, you'll get a carboxylic acid. Remember, for test 3, just like for test 2 and 1 and 4 and the final exam, your friends will be, do you break carbon-carbon single bonds? No. How many bonds to carbon? 4. How many bonds to carbon? 4. Did I tell you I'm ambidextrous? 4. Remember that when you're taking the test. Oh, one other thing. For those who get nervous taking a test, it's still in the announcement area, D2L. I have my video, how to use my method to eliminate test anxiety. You should watch it, and if you need help, reach out to me. And I know at least one student who's used it, and it's helped that student immensely. To whichever student who used it, I just gave you a big thumbs up. All right, so if you take an alcohol, now you can say, well, Dr. White, last and ketones are aldehydes, this makes an aldehyde. And the answer is yes, but it's hard to stop. You'll see at an aldehyde, why? Because an aldehyde can be oxidized to carboxylic acid. So for this test, if I have a primary alcohol or an aldehyde, you oxidize it, that's bracket O, close bracket. That means oxidation. You get a carboxylic acid, carbonyl, OH, R group. Now, one of my favorite ones, because it uses a Grignard reagent, is Grignard reagent with carbon dioxide, and you do this with dry ice, solid CO2, second step acid and water. You get a carboxylic acid that's 1 carbon longer than the R group you started with. You're making a carbon-carbon single bond. What happens is this attacks that. And X, as you know, can be, for this reaction, a Grignard, chlorine, bromine, or iodine. And those are the reactions I taught you for carboxylic acids. Now, if you replace the OH with OR in a carboxylic acid, you make an ester. An ester is a carbonyl with an R group, then also an oxygen to the carbonyl carbon, and on that oxygen is an R prime. This is an ester. If you go back, I think I tell the story of one class where I had a student named Esther. So every time I said, well, look at this Esther, she thought I was calling on her. She was glad when we got to the next functional group. All right, how do you name esters? For IUPAT, name the R prime as the alkyl group it is in front. Now, The carbonyl carbon, the R group, there are two possible ways of doing it. IUPAC is name the carboxylic acid. If this R prime was really H, name it. And then to name it as an ester, drop the OIC in the word acid and add ATE. Now, I had a very clever years ago Chem 170 student and said, well, why don't you do it this way, to be or not to be? Well, that's the question. I can't stop doing that, B2. But anyways, name the alkane from the longest chain of carbonyl carbon. So this R group plus the carbonyl carbon, you name as an alkane, drop the E and add OATE. And that both works. Either way, unless R is a benzene ring, and then you have to use 2A. And go back and look at how I make benzoate esters, name them. Now, I've only asked you to learn one common name of an ester, and that's this one. That's where R prime is ethyl, and here it comes from acetic acid, the common name for, if this R prime was H, drop the IC and add ATE, and this is ethyl acetate. And ethyl acetate is one of the two types of molecules that are nail polish remover. It used to be this was the dominant one, but when they started using the UV cured nail polish, they found acetone works better. But if you go into a big box store, guess what? You'll find some of the nail polish uses ethyl acetate. All right, now I talked about earlier, let's go back. This is a carboxylate anion. And the question is, how do you name those? Because they play a role in our daily life. Well, it's almost the same as esters. Step one, name M plus the cation, either it be lithium, sodium, or potassium, as the element it comes from in front. And then use either 2B or B2, 2A or 2B, just like you did a carboxylic acid, to name the rest of the molecule. So if I were to have the following, let's do one real quick. We have a carboxylate anion. And what's the element in front? The cation, it comes from sodium. Now, you could say this is propanoic acid and drop the IC in the word acid and add ATE, or say 1, 2, 3, propane. Drop the E, add OATE, either one, you get the same. Now, as I mentioned in my video, this carboxylate anion is a preservative in pop. And Dr. White used to be heavily addicted to pop. I gave it up a couple of years ago, but Dr. White used to love Dr. Pepper and Verner's. If you've never had Verner's, are you missing something? So how do you name it? It's a carboxylate anion, sodium in front. Now here, well, there's no longest chain, so you have to use the IUPAC way, and that's benzoic acid. Drop the IC in the word acid, add ATE, and that would be sodium benzoate. And the next time you have Coke, Pepsi, 7 Up, or my favorite, Dr. Pepper Vernors, you'll see on the label there's sodium benzoate, and it's a preservative. That way you won't get sick from your pop if it's been around a while. All right, important. Oh, it's time for me to be subtle. Don't you love when I'm subtle? Can't know this. Esters are responsible for the smell of most flowers and the taste and smell of many fruits and vegetables. So if you have the smell of rose, which Dr. White loves roses, and other flowers too, you're smelling an ester. How do you make an ester? Williams Fisher esterification. Carboxylic acid, alcohol, H plus acid catalyst, you make the ester. The OH is replaced by R prime O. Now, reactions of esters, and we'll come back to this first one because this is how your body breaks down fats and oils when you consume it. If you take an ester reacted with acid and water, you get back the carboxylic acid and the alcohol you would have used to make that ester. Next, if you take an ester and react it with a base and water, you get back the alcohol you would have used to make that ester, but in the presence of base, the carboxylic acid gives you the carboxylate anion. If you write here the carboxylic acid, I'll mark it wrong because in the presence of base MOH, it will react like I showed you earlier to form this carboxylate anion. Now, one of my favorite, why? Because there's a Grignard. I don't have here, so I better, it won't be on there, but you know, X can be chlorine, bromine, or iodine. If you take an ester and react it with 2 molecules of a Grignard, second step acid and water, you make not 1, but 2 carbon-carbon single bonds. Here's the carbonyl carbon and becomes this alcohol. Now this part of the ester gets kicked out to become this second alcohol. And Dr. White wants to have some fun, so let's have some fun. So the question would be, what's the products? There are 2 of them. I'm telling you that by putting a plus sign there. Once in a while on a test, I might forget to put the plus sign. If you see that, always feel free to email me to ask me, and I'll let everybody know there should have been one. So what's the functional group here? Carbonyl, oxygen to carbonyl, R prime, carbons on that oxygen, carbons on the carbonyl and ester. First step, carbon-carbon magnesium chloride. That's, I forgot to put the 2 there. You have 2 of the Grignard. Number X can be chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon. That's where the fun is. the R group is still attached to it. You make not one, but two carbon-carbon single bonds from the Grignard. This becomes an alcohol, and this part becomes the second alcohol. So R prime, R triple prime. My R group, CH3, to this carbon, which is now going to be this carbon, and it'll have an OH. And then my two R triple primes, and then my R group here, R prime is methyl. And now put in the hydrogens. And by starting with a very simple ester and a very simple Grignard, I've made a very complex alcohol. Usually you keep R prime small, so this alcohol you can distill off easily in real life. Oh, that was fun. Thank you for allowing me to have some fun. All right, next I started talking about an area I worked for a number of years in the chemical industry, amines and amine derivatives. An amine is a nitrogen derivative, N, that's made from ammonia, NH3. And you replace the hydrogens on the nitrogen ammonia with 1, 2, or 3 R groups, alkyl groups. Now, nobody uses IUPAC nomenclature, so I taught you the common name. For amines, name each R group as the alkyl group in front, and then add the word amine at this end. So if R in the first one was an ethyl group, this would be ethylamine. That's simple. Now there's a special amine, just like phenol, where you have NH2 group on a benzene ring, and that's a molecule that's been around for centuries. And the old name has been adopted as the IUPAC name, aniline. And aniline is used to make the dyes for your clothes, and also a lot of other things like the urethane that makes the pillows for your, or the foam for your pillows and your car seats and furniture, and other things. Now, something very near and dear to my heart is a quaternary ammonium salt. And that's where you have 4 groups on a nitrogen. This now has a positive charge. All molecules have a net zero charge. So you need the anion. For this class, I'm only using the halogen anions, chlorine, bromine, or iodine. How do you name this? Name each R group as the alkyl group in the front, then add the words ammonium halide. The halide, if it's Br, is bromide. If it's Cl, is chlorine. And if it's iodine, is iodide. Now, quaternary ammonium salts, and I have a number of US patents in quaternary ammonium salts that I invented, are used, one of the main use is fabric softener. The other one is an antimicrobial compound. They use quaternary ammonium compounds to disinfect hospital operating rooms. All right, now, and I've got this wrong and I apologize. This is an amine salt. There should be a plus sign there and an X minus. And you name that the same as a quaternary ammonium salt. Name the 4 R groups, or in this case 3, add the word ammonium halide, where Br is bromine, Cl is chloride, iodine is iodide. Now, how do you make amines? If you take an alkyl halide, Rx, where X can be chlorine, bromine, or iodine, react it with ammonia, NH3, this nitrogen attacks the carbon, bonds to the carbon with the halogen, and then you lose HX, which is neutralized by the base, and you get a primary amine. I will never ask what's a primary, secondary, tertiary amine, but I do use that terminology. If you have a primary amine reacted with an alkyl halide, same thing. This attacks or the carbon with the halogen, kicks it out, and you make a secondary amine. And finally, you have a secondary amine, and you react it with an alkyl halide, which could be the same or different. That's why I have R prime and R double prime. You, in the presence of base, to neutralize the HX, you get a tertiary amine. Now, one special reaction was actually the first reaction I ever assigned in the chemical industry to work on was this one, a nitrile, and I'll never ask you what the functional group is, but it has 2 bi-bonds and 1 sigma bond. And just like a carbon-carbon triple bond, a carbon-nitrogen triple bond can be halogenated with hydrogen excess, all the hydrogen in the world you need, and a catalyst, which can be nickel, platinum, or palladium. And each atom of the triple bond, C and N, gets 2 hydrogens, which I can write this way or this way, which is a primary amine, both of them. And that's what I worked on initially. All right, now, something very, very, let's do a third one, very near and dear to my heart, is this reaction. If you take a tertiary amine and react it with an alkyl halide, the non-bonding electrons in nitrogen attack the carbon with the halogen, and you form a quaternary ammonium salt. There are 4 R groups, but since you're using the nitrogen, non-bonding electrons of nitrogen, that will have a plus charge, and all molecules have a net 0 charge, so you need the X minus. And I worked for a company that made fabric softener, they still do, and I was in charge of all research in North America. And our 2 biggest customers were Procter and Gamble and Lever Brothers. You know them as Downey and Snuggle. And we made the molecule that actually did the fabric softening. So I think you might want to know this reaction. Hint. All right, now, amines are bases. A base is something that accepts a proton. HX is a hydrohalogen acid, and you have a proton transfer to make an amine salt. This is a straight acid-base reaction. Now, R and R prime, one or both or none, can be hydrogen. So that means you can start with a primary, secondary, or tertiary amine. And that's how you make an amine salt. And we'll see later on, amine salts play an important role how your body breaks down proteins to make amino acids, which are easily absorbed into your body as amine salts. Next, I'd like to talk about amides. Amide is the functional group where you have a carbonyl with a nitrogen attached to the carbonyl group. The carbonyl group has carbons R. The nitrogen has 2 R groups, R prime and R double prime. But note, in an amide, R prime and R double prime, one, both, or none, can be hydrogen. And I didn't ask you to learn any nomenclature for amides, but this is also an area I worked in the chemical industry. How do you make an amide? A carboxylic acid plus an amine or ammonia. Now notice R prime and R double prime can be hydrogen. One, both, or none. If they all are hydrogen, then this would be ammonia, which would also do the same reaction. But in this case, R prime and R double prime are hydrogens. And you make an amide. Now, let's talk about the reaction of amides. If you take an amide, and I'm only going to do one acid, it does it with all acids, but we're going to use, hydrochloric acid. Why? Because that's the acid in your stomach. I still think it's a miracle that all of us have cells in our body, in our stomach, that make hydrochloric acid. This is mind-boggling still to this day for me. But acid and water, HCl and water, you get back the carboxylic acid you would have used to make that amide, but the amine you used to make that in the presence of acid, HCl, forms the amine salt. The amine you get in the presence of HCl forms the amine salt. Now, remember, R prime and R double prime can be hydrogen, or they can be one or both alkyl groups too. Now, in base, if you have an amide, and the only base I'll use is sodium hydroxide, NaOH, in water, you get base hydrolysis of an amide. Now, instead of getting the carboxylic acid you would have used to make that amide, remember, base in a carboxylic acid gives you a carboxylate salt, which is what we get. But amine is the base, so you don't react it any further, you get back the amine. So you get back the carboxylate anion of the carboxylic acid you would have used to make that amide, plus the amine you would have used to make that amide. Remember, both R prime and R double prime, one or both, can be hydrogens or carbons too. All right, time for Dr. White to be subtle. I talked about heterocyclic compounds, and you should know what is a heterocyclic compound. That's a ring with carbon atoms and other atoms such as oxygen or nitrogen. And especially with nitrogen, these play an important role in some of the amino acids in our body are heterocyclic. Now, I'm only going to ask you to learn one heterocyclic compound. That's pyridine. And it's the common name in the IUPAC because pyridine's been around for eons. That's where you have a benzene ring, or it looks like a benzene ring, and one of the carbons in the ring you've replaced with a nitrogen. By the way, pyridine stinks. Not as bad as thiols, but close. Think of taking a dead fish, putting it in a Ziploc baggie in your backyard in the summer, and coming back a week and smelling it. Pyridine would probably smell worse. It's stinky, but it's an important compound. It makes pyridine as part of the quaternary ammonium salt in the mouthwash I use that keeps my gums nice and healthy. And with that, I'm done. Wow, this is a long night. I'm going to stick around a couple minutes for anybody who has any questions. Let me do something real quick. It's not working for me today. So I'm going to ask the person who I taught the method to stick around for a couple of minutes because I like to talk to that person. And with that, I'm done. If you have any questions, stick around. I'm going to say "Gang gesund," which means go in health in Yiddish. You've heard that story from the first video. And you know what's coming next. Yep. Bye now. Bye now. Stole that from Granny and the Beverly Hillbillies. Bye.